So in the previous videos, we introduced you the idea of the imaginary unit being used in complex numbers. And we ended with a series of calculations showing what different powers of I were equal to. And we kind of asked you the question, well, how would you go about finding I to the 51st power? Or for example, I to the 204th power. Well, there's a faster way to do it besides doing all the calculations in between. So we noticed when we went ahead and did the powers of I from I0 to I9, we noticed that it's the numbers, the answers cycled every 4 times. So for example, I to the 0 was the same answer as I to the 4th, which is the same answer as I to the 8th, right? So we could keep doing this all day long. If I keep adding 4s to this, I to the 12th, I to the 16th, etc., then all of these would be equal to each other. Well, what about the other ones in between? So then we have to ask the question, well, what was a cycle? So the cycle was 1, I, negative 1, negative I. And then it would repeat again. 1, I, negative 1, negative I. I would encourage you, if you forgot that pattern, to go back and look at the other notes to see that pattern and how it was developed. So welcome to Algebra 2, where we think things through a little deeply. What if we go ahead and we said use a variable n? And what if I gave you this equation, I to the 4n? And what if we plugged in these numbers right here, one at a time? So for example, if I plug in a 0 for n, I get I to the 0 power, and that's equal to 1. Or if I plugged in a 1 instead, 4 times 1 is 4, but we've already established that I to the 4 was 1. If I plug in a 2 instead, 4 times 2 is 8, but we already showed in the previous video that I to the 8 was 1. So interestingly enough, what we're proposing is I to the 4n power is equal to 1. In other words, what if n equals 10? If I plugged in a 10, that's I to the 40th power. And based on this, I to the 40th power is 1. You don't have to do what we did in the previous video and develop all of the ideas and break down all the exponents and see what is equal to what. What we're telling you now is that I to the 40th is 1. I to 4 times n is 1. You plug in whatever number you want for this, and you're going to get it equal to 1. This is powerful because now you don't have to worry about doing everything leading up to 40, right? You don't have to do I to the 10, I to the 11, I to the 12, etc. You can just say, I want I to the 40. Boom, it's 1. But how do you know, Mr. River? How do you use this? Well, hold that thought. So this takes care of all of the ones where the answer is equal to 1. And remember, the cycle is 1, I, negative 1, negative I. So we took care of everything that's equal to 1. Everything that's equal to 1 is this formula right here. You pick it, we plug it in. You want I to the 400th power. I plug in a 100. I get I to the 400 is 1. So what about this one? What about all the ones where it's equal to I? Well, remember in our cycle, if you look at the patterns, this was I to the 0 power. This is I to the 1 power. What if I take this previous equation and I went ahead and all I did was add 1 just to bump it up? We get this equation right here. What if I want to get this one? I could take the same equation, right? Or even the previous one, and go 1 up more. These are general cases. These are things that allow us to go ahead and figure things out. What about this last one? So this one belongs to this. And if you plug in any number you want, you're going to get one of these 4 options. Now, what does this look like? How do you use it? Now that I've fried your brain with theory, let's tell you what to do with it. I to the 51 power. All those previous little formulas that we came up with, you'll notice that they all had 4n in the equations. And where did that 4 come from? Well, because the powers cycled through the same 4 answers. 1, I, -1, -I. So this is the most important part of the entire video. Remember our first 4 powers of I0, I1, I2, I3. And they were 1, I, -1, -I. And it cycles through the same thing. May I propose you the following? And this is going to make a lot of sense in a minute. If your remainder is this, then the answer is this. So for example, whatever this means, right? If the remainder is 2, the answer is -1. Or if the remainder is 3, the answer is -I. Or if there's a remainder, the answer is 1. Okay, brace yourself for the easiest thing on earth. So how do I find I to the 51 power? You take that 51. Well, this one might be easy if you didn't pass your division in 4th grade. I'm going to divide this by 4. And why am I dividing this by 4? Spoiler alert. Because the answers cycle every 4 times. They cycle through 1, I, -1, -I. So I'm going to take this power and divide it by 4. And if I do that, I get a remainder of 1. No, silly boy and silly girl and silly whoever you are. Keep going. Bring down this 1. And then I'm going to go ahead and do a 2. 4 times 2 is 8. And I honestly can't help you much if you don't know how to do elementary long division. So hit me up on Remind or email me or check out a YouTube video somewhere else. 11 minus 8 is 3. The remainder is 3. The remainder is 3. So the answer is -I. What, Mr. Rover? The answer is -I. That's it. That's it. That's it. Let's do a different problem. Let's try I to the 78 power. So we take the 78, we divide it by 4. Mr. Rover, why do we divide by 4? First of all, you always divide these powers by 4. Why? Because we noticed that the powers, the answers, cycle through every 4 times. They cycle between 1, I, -1, -I, in that order, over and over again. Okay. Well, Mr. Rover, what if I do this and then I get a different remainder like 4 or 5? You divided wrong. Okay. I'm telling you right now, if you divide by 4, you're gonna get one of these remainders, and that's it. So if you get something else beside that, you divided wrong. Okay. Let's do this. So that's a 1, 4, 3. Bring down the 8. This is going to be 8, 32. Remainder 6. But Mr. Rover, you told me. I know. I wanted to show you what people tend to do. That's wrong. That was supposed to be a 9. So 4 times 9 is 36. Remainder of 2. So if the remainder is 2, my answer is -1. So this is equal to -1. I to the 78 equals -1. But Mr. Rover, I'm confused. What do I do with the 19? Nothing. We just care about the remainder. Okay? Because what this is telling me is that it would take me 19 cycles of problem whatever from the last lecture notes to get I to the 78 by hand. So this would be like a 10-hour lecture video. Ain't nobody got time for that. So we don't care about this right here. This has no significance to us. All I'm telling you to do is divide this power by 4, see what the remainder is, compare it to your little chart, and then get the desired results.